Okay, y'all, this is section 1.2 and 1.3 angles. First things first, let's define what an angle is. Okay, you may need to pause this video in order to write everything down, so if you need to, do that. So an angle is going to be formed by two rays. You should know what a ray is, because that's what we learned in section 1.1. So it's formed by two rays. They share one common endpoint. This common endpoint is called a vertex. Okay, so you'll hear us say vertex throughout the entire year, or vertices for plural. And then the rays are also known as the sides. So if you hear us say that, you know what we're talking about. Okay, here's what a picture of an angle looks like. And then you name it like this. You have to use 3 letters. Okay, sometimes you can use 1, but for the most part, you are using 3. So here's how you name the angle. Okay, and of course, you can also reverse the letters N-A-T. Okay, and then you can also name this one with just 1 letter, only because it's an angle all by itself. Okay, this is hardly used. We mostly use 3 letters. Talking about the sides, okay, the sides of the angle are rays AM and rays AT. So if I ask you to name the sides, but you have to do that in your homework, that's how you would do that. If I ask you to name the vertex, all you would say is A. Okay, and that's an angle. The measure of an angle. You can measure an angle with degrees. Right? There's a special tool you use. But if you want to say how big is an angle, you give the measure in degrees. So it's the smallest amount of rotation about the vertex from one ray to the other. So from there to there. So in this example, it's 43 degrees. Congruent angles. Talk about congruent segments in 1.1. When you have congruent angles, it's just 2 angles or more whose measures are equal. So here's an example of 2 congruent angles. You could also possibly see this symbol here and here. So if they don't have any measures, when you see those 2 tick marks, then that's signifying that they're congruent. Protractor, and most of y'all might have used this last year, maybe one time or another. It's a geometry tool to measure angles. Okay, this is what it looks like. Okay, so let's practice using the protractor. If you don't have one, just kind of jot down and see how we're doing this. So let's measure these angles. The way you want to measure them, you want to put this point right here and that point on the vertex. So in this case, our vertex is at E. So we're going to place our protractor like that. Okay, so looking at these angles, angle AEB, the measure of angle AEB is starting at this 0 right here on the outside numbers. The outside numbers all the way to the top, it's 90 degrees. Okay, let's do the measure of angle DEC. Notice the zeros now on the inside. So we're going to start here at 0, go up, and that is about 50 degrees. And mine might be a little bit different from your picture. Okay, so if you're using your protractor at home on measuring these, it might be a different number. So don't think it's incorrect. Actually, I think that looks like it's 51 degrees. Because if you look closely there, it's on the second tick mark. So let's change that. 51 degrees. Okay, and then let's do one more angle. Let's do the measure of angle BEC. BEC. So there's a couple different ways you could do that. You can do some subtracting here, okay? Or you can turn the protractor so that way one of the rays ends up being on the 0. That's where you always want to start, on a 0. So you can see the inside numbers are what we need to use again. first step is to draw a line, like you see here. You draw a line and then you can name that endpoint. That'll be your vertex. The second step is to make an arc like that and make that same arc over here. And that's going to be the point E. Then you want to measure from B to C with your compass, come back to E and make that red arc like you see there. And then that intersection point right there, all you do is take a ruler and draw that last step. Okay, so 4 easy steps. So let's practice that together on this one here. So let me get my compass and my ruler. Okay, so first things first, we want to draw a line. Draw a line. That's step 1. Step 2, it says to make an arc on the angle that you're copying. So everybody place your compass on the vertex. And here's where the width of your compass does not matter. Okay, so you just have to make an arc there. Come over to the line. I should probably label some points here. So let's go ahead and label this, I don't care, 8. And this is technically kind of like an arrow. So place your compass on A, and then make that same arc like we just did. Okay, I didn't change my compass setting. Can't do that. Pause this video if you need to catch up. Okay, and then the next thing you want to do is, and I should highlight these 2 points. Okay, this point and this point are pretty important because that's what we want to measure. So we want to measure how far apart they are. So if you also want to label them, you can. So let's label that one M and N. So we'll place it here. Bring it in. I'm recording my feet. Okay, come back in about 10 minutes. Sorry. See how wide it is. Place it on this point over here, and then you want to make an arc. Okay? And so then the last step here is to put your straight edge on the vertex and through that intersection point right there. And draw a line. Okay? So that angle is going to be identical to that angle. So let's put some tick marks on there. That angle is congruent to that one. And that's it. So let's write a little note also that you must have 1, 2, 3 arcs. Okay? Must have 3 arcs. Okay? 1 over here, and then these 2 on this side over here. Okay, now we're constructing angles. Angle bisector, definition. Angle bisector is a ray, as you know what a ray is, that divides an angle into 2 congruent angles. So here's a picture of what an angle bisector looks like. I'll highlight that. This here, ray AW, is the angle bisector of angle DAG. Okay, so our angle bisector here is AW. Make sure you name the ray correctly. If it bisects the whole entire angle, then that makes this angle congruent to this angle. Okay, you can also add some measurements to that. If this is 40 degrees, then this one is 40 degrees. Okay, so angle DAW is congruent to angle WAG. See here, we cannot name the angle with one letter. If I say angle A, well, there's 3 different angles there. Okay, cannot name that with just one letter. Okay, so let's construct an angle bisector. Okay, that term that I just talked about. It's 3 simple steps. First things first, we want to draw an arc, and this can be any size. So that red arc that I just highlighted. Then you want to place your compass on B and C, kind of get that width, okay? It doesn't have to be exactly, it just needs to be around there. And then you make an arc from B to right there, and then you make an arc from C right here until you see them intersect. And then that intersection point you want to connect with vertex A. Okay, so let's do that. This one's a little easier than copying an angle. Okay. Put my compass in the ruler. Okay, this one, or bisect the same here. So place your compass on the vertex, and then you can get any setting. Don't do a super small one, okay? It becomes inaccurate when you do that. Okay, and then make an arc. Then you want to place your compass on these two intersection points. And again, it just needs to be close to it. It doesn't have to be exactly. So see how I'm like right here, that would still be okay. Okay, so that you can go right on it if you want to even go further out. Okay, it just needs to be about right there. Then you want to make an arc in the interior, like that. Then you want to place it on the other highlighted point and make an arc so that you see them intersect. That's the other important point right there. And then the last step is to get your ruler, line up the vertex, and that intersection point right there. Try to be real precise. And then draw a line through it like that, or a ray. So you just bisected this angle. That means this side, or this angle, is going to run to that angle. And that's our angle bisector. So how many arcs do we need? We need 3 arcs to get this one correct. Okay, moving along. Another definition, skew lines. Skew lines are lines that do not intersect and are non-coplanar. So every year students have a hard time with this one, okay? So this is line M, and this is line N. These are an example of some skew lines. Line M and line N are skew. These two lines will never intersect and they will never, or they're not on the same plane. Some people think that if I continue it this way, will they intersect here? Well, yes, they intersect on paper, okay? That's two-dimensional, but this right here is a 3D picture. And so you have to have your mind in 3D mode. So this right here, they won't intersect. And this one's way down here, and that one's way at the top. So these two will intersect and they're not on the same plane. Be able to identify skew lines. Okay, right angle. Y'all might have remembered this from middle school. An angle that is 90 degrees. Remember that this box signifies 90 degrees. Okay, so they don't always have to write that. They can just draw a box. Acute angle. An acute angle is an example of an angle that is less than 90 degrees. So there's a picture there. Okay, anything that's less than 90 degrees. Obtuse angle. An angle that is greater than 90 but less than 180. So that clock has a picture of the hands that are in the obtuse angle, and then you've got one over here to the right. Adjacent angles. Adjacent angles are angles that share a common ray. So here's a picture of adjacent angles. This angle here, angle 1, and this angle here, angle 2, those are adjacent angles, okay, because they share this common ray right here. They share a side. Complementary angles. Complementary angles are angles whose sum of their measures is 90 degrees. So here's an example over here, 35 and 55, and then here's one here, 40 and 50. Supplementary angles. Angles whose sum measures is 180. protractor and measure from there to there on a flat line, it's always going to be 180. Okay, vertical angles. Vertical angles, okay, we will get from this picture right here. So let me show you on the left here. You've got angle 1 and 2 that are vertical. You've got angle 3 and 4 that are vertical. Okay, so this one and this one are, see the little color, this one and this one are. Okay, same thing over here. This angle and this angle are vertical. This one and this one are vertical. Here are some examples that are not vertical angles. So if you had to come up with a definition in our own words, we would probably say something like this. Two angles formed by intersecting lines. If they're not intersecting lines, then you can't have vertical angles. Okay, two angles formed by intersecting lines and are non-adjacent. The word adjacent means right next to each other. Okay, so they're not going to share a ring. So they're all like on opposite sides. So some people like to do that, opposite in parentheses or across from each other. Linear pair of angles. So here's some examples of some linear pairs. Angle 1 and angle 3. Angle 4 and angle 2. Angles 1 and angle 4. And then last pair, angle 3 and angle 2. Okay. This one down here, angle 1 and angle 2. Over here, I'm not going to name all of these, but those two right there would be a linear pair. These two over here would be a linear pair. These are all examples that are not linear pairs. So a good definition, we could say, are two angles formed by a line and a ray. Okay? A line and a ray. And it can also be two intersecting lines, but that still falls under that right there. Okay? Here we have a line and a ray at the very bottom. So it's two angles formed by a line and a ray that are adjacent. So you have to have them right next to each other. Okay? Angle addition. Angle addition, all that means is if D is in the interior, so I just put that in the interior, okay, then you have an angle here, which we'll call angle 1, and then you have an angle here that we'll call angle 2, and then of course you have the entire angle there. So all it's saying is that angle 1, which is right here, plus angle 2, right here, that's going to equal the whole entire angle. So kind of like the segments that we did at 1.1. So let's try some problem examples. So whenever you have this and you'll have this on your homework, you want to draw out the picture. So angle R is in the interior of the axis, so draw that first. Okay, that's, and then R is in the interior. So you want to connect that, and then we have two angles that add up to a line. So it says angle AXS is 76 degrees, so the whole thing is 76 degrees. RXS is x plus 12 degrees. And then AXR is 7x plus 4 degrees. So the way you want to set this one out is add those two in your head. That's 8x, right? 7x plus 7 is 8x. Plus 16 is equal to 76 degrees. Okay? So if you can't go straight to that step, write this step out first. then I'm going to have to plug it in to solve for the angle. So this one's easier. 7.5 plus 12 is 19.5 degrees. And then subtract that from 76, and you get 54. Nope, I did that wrong. Erase that. Five. Okay, so then you have to measure all these. Okay, let's try another one. Measure angle ABC is 5x plus 32. BD is an angle bisector. Okay, you'll have this one on your homework. Make sure you highlight that, make a note of that. What does it mean to bisect? So let's draw a picture. ABC. BD is the bisector, so draw it right down the middle. So this is congruent to that. It's cutting it in half. Notice I put those tick marks right away. So the whole thing, ABC, is 5x plus 32. And DEA is 4x plus 4. Okay? Well, these two are congruent, so I'm going to just write that again, 4x plus 4. Okay? So when you make a picture, it makes things easier. So 2 of 4x plus 4 is 8x plus 8. I'm going to set that equal to the whole thing, 5x plus 32. So I'm going to minus 5x, this is all algebra 1 stuff, minus 8. 3x is equal to 24. Pause this video if I'm going too fast. Divide by 3, x equals 8. So 8 will get plugged back in to find these measures. So 8 times 4 is 32. 32 plus 4 is